Okay, hi guys. My name is Nemish. I've been using Scala for quite some time, and I love different programming languages. And I was impressed with the macro system introduced in such a language called Nemish, or I'm not sure how it's spelled. And I was very excited when I saw that Eugen Bormako introduced quite similar approach for Scala compiler. And I was wondering what could possibly be done with this tool. That's actually how JScala project was started. Is there someone who already seen me presenting JScala before? Oh, that's cool, because it's going to be quite similar. Okay, so what is JScala? Previously we experienced a presentation by Otto about Scala.js, so that's pretty much similar library, but done in a totally different way. So it's a set of markers and macro annotations which almost literally convert Scala code into JavaScript. So the library contains actually macros and macro annotations. Also, it contains a JavaScript AST, abstract syntax string, pretty printer, which you can create this AST manually or create from the Scala code, and you can manipulate those trees if you like, and then pretty print to a string, which is actually what's the actual point of this library. Also, we have this feature which also Otto mentioned before. It's a TypeScript import. So if you have a library, JavaScript library, which has a TypeScript annotation file, you can import it and use it, actually. I'll show the examples on the next slides. So why would you use JScala? Maybe instead of JavaScript, maybe instead of Scala.js. Well, first is a light bandity or type safety. What I usually mean by that, I include into this is actual IDE support, which is quite important in modern large projects, because I'm not considering dynamic languages very serious for large projects, mainly because of lack of support of IDE, because you have to have a decent navigation and refactoring possibilities in large projects, otherwise you're screwed. So it's IDE support. Modularity, you can use classes, traits, to modularize the code. Single language. As Otto mentioned before, we would like to use single language, which not most, but some JavaScript programmers do when use Node for server side. And less boilerplate, of course. If you ever seen CoffeeScript or even used it, the main purpose of that language is to reduce boilerplate of JavaScript. So JScala can be used for these purposes too. So let's take a look at the example. The main difference of JScala compared to Scala.js that it does not require any runtime. So we have this, I don't have a pointer, sorry. Oh, okay. So we have this thing which looks like a function, like a usual Scala function called JavaScript. This is actually a JScala macros, which takes a block of code and tries to convert it into a JavaScript AST. If we print this using this sString method, we'll get this JavaScript, which is quite straightforward. You can see that on first line we had if expression, then we had a pattern matching and a call of print. So we get a ternary expression in JavaScript, because we know that ifs are not expressions but statements in JavaScript for some weird reason. And we have a pattern matching converted into a switch. And we have a call of print. So it's very straightforward. So if there is a simple way to convert Scala to JavaScript, or you have an intuition how it should be done, in most cases it's done that way. That means you have no boilerplate, as I said before, no runtime, and this can be used to produce. Well, sometimes you need to generate JavaScript logic based on some conditions on server side. So JScala is good for this kind of tasks, because otherwise you would either concatenate strings or you'll create another JavaScript AST and we'll do a list programming on your own. So, what features does JScala have? So we can define variables, functions, and lambdas. Ifs, loops are supported. We have a limited support of pattern matching without guards, unfortunately, yet. Exceptions, try-through methods are also supported. We have a limited support of classes and traits, and limited support of inheritance. Only methods can be inherited. Also, we have a JS dynamic for dynamic programming. Whenever you have, you want to just call any method on a given object, supposing that you have it implemented somewhere in JavaScript library. It's similar to Scala.js. So you can use this JS dynamic. I'll show you examples. And we have an injection, which allows you to insert your server-side data into generated JavaScript. So, first of all, we can use it for manual AST transformations. So we can define a variable called test and say it's going to be a map. We can use JS to create it, or we can do a list kind of programming and create those AST by yourselves. You can concatenate those, insert, so we can build quite complex logic using just manual ASTs. So we can see the results that we have a variable test, which is an object, and call of print. Okay. So let's take a look at more complex example. Let's say this code does not actually make much sense. It's more like example of different features. So you can see that we create an array here. We can include a raw JavaScript using function include. And we can define this JS dynamic $sign which we can call any methods on, and it's gonna be translated literally into this line. Oh, I don't have a pointer, sorry. So let's see what's gonna be generated. Quite straightforward. We have an array, we have a raw JavaScript line included, we have a simple for, and this jQuery line just inserted literally. So this quite basic set of features allowed me to port JavaScript implementation of Tetris to Scala, which included in this JavaScript macro produces JavaScript which is actually playable. So I have this, 1 second. Give it a few seconds to compile, sorry. So basically what happens is I have this file. Which have this implementation of Tetris. It has a class representing canvas, statistics, a bunch of methods defined, and a lot of logic. So just take a look. It gets compiled to JavaScript, put it into a browser, and it actually works. One second. So it's like 400 lines of code of Scala, which gets converted to JavaScript, which actually works in browser, which was surprising even for me. Okay. So the next thing you can use JScala is for sharing server-side and client-side code. It's not in this position when you can write very complex logic, but for small things like validation, you can share server-side and client-side code using JScala. Similar to Scala.js, but without boilerplate thing. So in this case, we're using annotations, macro annotations. So basically, you annotate a class which contains your logic which you want to share with this JavaScript annotation, and this macro annotation generates the JavaScript implementation of those methods of the class greeter in this case. So if we call this method hello from Scala, from JVM, it's gonna print hello Alex. And if we call this JSON method, or JS method, we'll get an implementation of this greeter class in JavaScript. We can evaluate it using Merino, for example, and we will have quite the same result. So this is what's going to be generated. And when we evaluate it, it's going to get the same result. So I was wondering what can be done using this feature. I was willing to implement quite complex logic and share it on server side and client side. So I implemented AES encryption, which you should not use, but just for fun. So this is a Scala implementation of AES encryption algorithms. You can see it's quite a lot of code, which uses a lot of bits shifting, all that kind of stuff. And I wrote this play application. Which is working like that. Whatever I write in this text area gets encrypted using JavaScript generated from Scala class. It gets passed to a server side, encrypted, and then on the server side, this message gets decrypted using the Scala version of the same algorithm, the same code. So whatever we write here, we get a bunch of an array of integers, which is a encrypted representation of this message. We send it, decrypt, and server side returns message decrypted. And this looks like that. Also, as I mentioned before, we can do a small validation shared bits using JScala. For example, let's take a look at sign-up form. So we have this form, which should be one of these fields should be validated. We say that we want username to be larger than 3 symbols. So we can write a Scala code annotated with JavaScript, and we will have a JavaScript we can use. So we have the same code, which actually does not allow me to send this form until I make it longer. Then it works. Just want to show you that I have the same code validating this field on a server side. But when you want to write, you want to do actual JavaScript programming, you need to use a lot of libraries: jQuery, React, Angular, you name it. So it would be nice to have the IDE support I mentioned before. So you need something to know. We need somehow to know all the methods, all the data structures we have in those libraries. But similar to the Scala.js, we can import TypeScript annotated TypeScript annotation files for those libraries. I'm not sure Did someone use TypeScript notations? No? So, as you may know, Microsoft have developed this TypeScript language, which should be a typed JavaScript. And a lot of JavaScript libraries have TypeScript files, which will have a lot of type annotated functions for libraries. For example, JavaScript, for jQuery, they have this file, jQuery something TS, which contains all the methods, all the data structures in jQuery, so we can get a decent IDE support. For example, let's take a look. So we can, using this TypeScript annotation, we can import the TypeScript file, for example, for Angular or for jQuery, in this example, and we'll get a support, ID support, for example, add class. Come on, I know we can do it. Yeah, sorry, worked on my machine. It's better. But it works, I assure you, sometimes. Okay. By the way, for some reason, well, I know there is. Unfortunately, this feature works only in Eclipse, in Scala IDE, because they actually use Scala presentation compiler to roll out macros and macro annotations. Unfortunately, IDEA has its own kind of parser which does not support macros. It does not roll over macros. So in IDEA, it's gonna be just syntax errors. But it works anyway.
Yeah, it works. It compiles, but implementing IDEA published course in October 2015, and they provided API for implementing IDEA 15, where you can build a plugin to handle this kind of sometimes contradiction. Yeah, I did it also for my thing.
It works.
Yeah, it works.
So basically, what's been said that IDEA has a support.
Yeah, it's an API.
API for that. Okay. Maybe someday. Okay. Let's go deeper. So in a nutshell, that's all the features we have. So we can share code, we can write Scala, which gets translated to JavaScript straightforward, which you can use to generate the logic on a server side. You can write validations. Also, I was supposed to complete this SBT plugin for Play, which unfortunately I haven't done, but I will next week, which would allow you to write a JavaScript, Scala code, which gets translated to JavaScript in this SBT pipeline. Have you write Play applications, someone? So they have, they have this build pipeline in SBT, which converts your CoffeeScript, JavaScript, or do this GC, or whatever steps you need to do. So one of those plugins is going to be this JScala plugin, which will convert Scala to JavaScript. So you can include it into your Play build pipeline easily. So the cons of JScala. So currently, and probably anyway, it will support only subset of Scala features as a language, because it's quite complicated task to translate all the possible trees, Scala trees, into JavaScript. It does not cover the library, so it has a very limited support working with arrays, and that's it. So we can't use Scala Collections. One of the ideas of future development is to use any external libraries like underscore or whatever is currently best to convert Scala Collections methods to these underscore methods. And of course, JScala uses experimental features. It's macros, they evolve, they change. So you should use it with caution. Okay, the future development. I've been in this, positive feedback loop when I don't do much of new development because no one asks me to, because no one uses it. And no one uses it because I don't do any development of this tool. So please guys join, whoever interested in macros and JavaScript development using Scala. Just add me on Skype or email me. We can build it. We can make it better. One of the features I would like to implement is asm.js support, which, does anyone knows what asm.js is? A few. Okay, so basically it's a tool for making JavaScript code more performant by giving a JavaScript virtual machine hints about types. So basically we can say that this is an array of integers and then it gets much better performance. And in case of JScala we know the types, so we can do these hints automatically, because guys in JavaScript have to do this manually. And we can do this automatically, which would be great. So if someone wants to implement this kind of thing, just tell me. And about the plugin, I already said it. It's going to be on the next week. So we can try it. Join. So those are contacts. If you want to try it, fork it, or make a pull request, it's on the GitHub. Admin Skype, ask any questions. Thank you. Questions? One second, microphone.
Are you going to use Scala Meta later for macros?
Scala Meta.
Are you going to use Scala Meta for macros?
Yes, sure. I'm not sure on which state the Scala Meta is. I'm currently using what's in a compiler currently, and we'll see. Oh, yes, sure. One day.
You said that Scala supports only the subset of Scala. What happens when you write a code that is not supporting subset?
So the question was, given that JScala only supports subset of Scala, what happens when you write something that's not supported? Well, actually it's a compile time error in most cases.
What error messages look like?
They are ugly. Most cases they throw you with AST, Scala AST. Just for me, for debugging in most cases, what I did, I just wrote code, got this compilation error, copied the tree, inserted into JScala for it to be supported. So currently it's not cool. So don't use it for production, or maybe use it and we'll get it better and production ready. No questions? Okay, thank you.